Hi my friends, welcome to Collabshare channel. I'm Ramin, and in this video we're going to create a Docker image and a Kubernetes cluster for Postgres database. This process involves 4 steps which I highlighted them here. In the first step, we need to write a simple Docker file and build it, and then we will test the Postgres image using pgAdmin. After that, we will write Kubernetes YAML files for our Postgres cluster, and finally we will test the connection using again the pgAdmin. So let's get started. First of all, let's create directory structure for saving all database related files in there. First of all, we will create a directory with the name of dbs, and inside that directory we will create another directory for Postgres Django, because we may have other databases in our project, so we put all databases in one directory. Now we are ready to open the Visual Studio Code, and first we need to create a Docker file and write some simple instructions to pull the Postgres image and build it. The first line tells Docker that to pull the latest Postgres image, and after that we define 3 environment variables that actually are necessary to use Postgres. The first of them is Postgres user, which we define it as DJ_PG. The second one is the password. These 2 credentials are necessary to connect to the Postgres database. The third environment variable, Postgres_DB, is the name of the database that we are going to connect. And remember that these credentials are also required to be added to the Django settings.py. And finally we expose the default port for Postgres, which is 5432. Now let's save the file and build. Now let's create Postgres image using docker build command. I suppose to create Docker file inside this directory, so let's move Docker file to the Postgres directory. Okay, now everything seems fine. Let's go to the Postgres Django directory, clear screen, and now we are ready to build the image. Docker build, tag the image with Collabshare Postgres. You can tag it with whatever name you want, and using the Docker file in current directory we build the image. Now that the image is built, we can test it using Docker run in detached mode with the name of, we named the container postg, and we expose the port 5432 to the host machine, and we use the Collabshare Postgres image to build the container. So our container name will be postg. Let's create a container, and now let's see the logs of the container using docker logs-f with the name of the container. The last line shows that database system is ready to accept connections. So let's check the connection using telnet command. Telnet localhost 5432. And yes, our telnet command were able to connect to localhost with the port 5432, which is the port for Postgres. So our initial setup is working properly. Now let's check the database using the pgAdmin. pgAdmin is a popular open source administration and management for the Postgres database. It provides a graphical user interface for managing Postgres databases and allowing users to easily create, modify, and delete databases. And actually, pgAdmin allows users to connect to local or remote Postgres servers and view and edit database content. It has lots of capabilities. To download and install pgAdmin 4 in your workstation, you can go to the download page and find the installation method or installation file based on your operating system. After installing pgAdmin, we can run it, and using the credentials defined in the Docker file, we can connect to our Collabshare.dev database. To add a new server or to connect to our new server, we can go to add new server and fill the required fields inside this form. We call the name as test pg, and we connect to the local host with this port, default port, and the username was dj_pg. The password is mypass. And now if we save, we can connect to our database. And as you can see, Collabshare.dev database is here. We created it using this line, Collabshare.dev. Now we have successfully connected to our database. Let's check how we can create Kubernetes cluster for our Postgres database. Before creating Kubernetes cluster for our Postgres database, let's kill the Docker container, or actually remove and stop their Docker container. And after that, we also need to push the image to the Docker hub. So let's do all of these required steps. Docker stop post g, Docker rm post g, remove the container, and we also need to push the container to push the image to the Docker hub. Collabshare Postgres. Now that the image was successfully pushed to the Docker hub, let's create a directory to put all Kubernetes related files in that. Kubernetes. And now let's open VS Code, and I believe let's reopen the VS Code in this directory. Okay, and inside the Kubernetes we want to create 5 files, and I describe these files one by one. First, let's create the files. First, we need a PV file, which stands for persistent volume. And after that, we also need pvc.yaml file, which is for persistent volume claim. We also need a deployment.yaml file to creating the container and the pod, and then we need service.yaml file for creating a service for our pod, and finally we need an Ingress.yaml file Before writing instructions for PV and PVC files, let's see what is persistent volumes and what is persistent volume claim. A persistent volume or PV and a persistent volume claim or PVC are two Kubernetes objects that are used together to provide persistent storage for applications running in the cluster. A persistent volume is a cluster-wide resource that represents a piece of storage that is available for use by pods. It is provisioned by an administrator or dynamically provisioned by a storage class. A PV is a way to decouple the storage capacity from the pod that uses it, which makes it easier to manage and reuse storage resources. A persistent volume claim, on the other hand, is a request for a specific amount of storage from the cluster's available pool of storage resources. A PVC is created by a pod that needs to use persistent storage and specify the desired storage capacity, access mode, and other parameters. The Kubernetes control plane then matches the PVC with an appropriate PV that satisfies their request. In summary, a PV represents a piece of storage that is available for use, and a PVC requests a specific amount of that storage. Together, they provide a way for pods to use persistent storage in a decoupled and portable way. Now let's write the PV and PVC YAML files. It is pretty straightforward and easy to write PV and PVC files. First, we need to define the kind of the YAML file that we are creating, which is persistent volume, the API version, metadata, or in the metadata we provide the name for our PV, and we specify the capacity, which is 1 GB, access mode, read write many, we can change it, read write once, and many other parameters. And also the storage class name, which I provided manual here. You can specify various other types of storage classes that available, but as I need to do it manually, I provided it manual. And host path, which is the file where the database content will be saved on the host machine. Remember to put the absolute path here, otherwise you will face errors when creating pods and containers inside the Kubernetes. So this is a simple persistent volume file. Now let's write the PVC file, which is also similar and actually easy to write. The kind of this file is persistent volume claim. We name it as Postgres PVC, and we use the storage class name as defined here, manual, and access mode is read write mini, and the storage that we want is 1 gig. So this is these two files defines our where our database file will be saved in our host machine. Later on, when we write the deployment.yaml file, we will use this PVC file and we will attach it to the Postgres database. For the deployment file, let's go from top to bottom. The kind of this file is of course a deployment file, which we want to create containers with this file. The name of this deployment is Postgres deployment, and we want one replica set, and the important section is the spec section, that we define the container, which is the container that we have built so far, which is the Collabshare Postgres container. We provide the port, which is the default port 5432, and the most important part that is related to the PVC is volume mounts. And in this part we provide an storage which is defined in this volume, and in this volume we claimed a persistent volume from the Kubernetes, and the name of this claim is Postgres PVC, which we defined here. Now this volume will be mounted to the default storage path of Postgres inside the container. So now we can access to this path or the data in the container using PVC in our local host. This is the relationship between deployment, PVC, and PV. Now we are ready to define service and ingress file. First, let's define the service file, which is pretty straightforward. And of course, the kind of this file, this YAML file, is service, which is one of Kubernetes objects. The name of this service is Postgres service, and the app that this service will be attached is the Postgres, which is defined here. And of course, these ports will be utilized, and the type of this service is load balancer. You can use other types such as node port or cluster IP, but this one works better and without any further adjustment. And of course, we can access the Postgres database using Ingress with these definitions. The kind of this file, and of course this is an Kubernetes object, is Ingress. The name of this Ingress file is Postgres Ingress, and we use these annotations. And the host that we can access this the Postgres server is postgres.local, which we will define it in the etc hosts file, and the service that this Ingress file is attached is the Postgres service. Now that we have everything for our Postgres Kubernetes cluster, we can test and we can build the cluster and see how we can access to the Postgres data using pgAdmin. Let's run our Minikube cluster. Minikube start, and remember to enable Ingress add-ons after Minikube started successfully, and it takes some time to configure and boot the Minikube cluster. Okay, now let's Minikube add-ons, enable Ingress, and let's open another terminal window and access to Minikube dashboard. It takes some time. It is now enabling Ingress and also the dashboard. Now that the Ingress add-on is enabled, let's clear the screen, and now we can use kubectl command to apply all the Kubernetes files. But an important point to remember is that before applying deployment.yaml file, first apply pv.yaml file and then pvc.yaml file, because when you apply deployment.yaml file before these two files, it will cause the container to stop creating, because it cannot find the PVC claim, the PVC and PVC files. So remember to first apply these two YAML files, and then we can apply the other files. Apply that cube. Now let's check if everything is working properly. This is the dashboard of our. Okay, now we see that our Postgres dashboard, our Postgres pod is running without any issue, and we are ready to access the Postgres database using pgAdmin. Before using pgAdmin, we need to first of all enable Minikube tunnel. Without enabling this, we cannot access our Postgres database. Now that the tunnel is enabled, let's create new server with the name of K8 Postgres, and again the local host, the username was djpg, and the password was mypass. Okay, now we have successfully connected to our Postgres database inside Kubernetes cluster. This is how we can access to the Postgres database using IP address. We can also use the Ingress capability and access our database using the Postgres.local name that we have defined in our Ingress file. Let's check this option too. First, we need to go to the etc hosts and add Postgres.local to our etc hosts. It is required. Now, after adding that line of code to the etc hosts, we can actually check if it is work or not. Let's remove this server and add a new server with the same name, but this time we use Postgres.local to access to the Postgres database inside the Kubernetes. The name was djpg and the password was mypass. Okay, now we have connected successfully again, but this time using Ingress. Let's check. Connecting using Ingress is a bit time consuming, but it works properly, and now we have our database up and running, and we can manage our Kubernetes database cluster using pgAdmin. The next step would be to connect our Django microservice to the Postgres microservice. To do so, we need to modify the Django's setting.py file and add Postgres credentials to that file. Also, we need to install some packages, Python packages inside our Django virtual environment to be able to access Postgres database. And these are the tasks for the next video. I hope you enjoyed the video and see you